Good morning, everybody. Today is 14th December 2020. The day is Monday. My name is Ferhan Mazher, and right now I am with the 10 Cambridge class. The subject we are studying is Physics 5054, and today's main task is to start a new chapter. You see, we are starting a chapter. The name of the chapter is Static Electricity. So in this, we will be studying about positive and negative charges, charges, atoms, and electrons, electrons, insulators, and conductor, the electrostatic induction, attraction between the uncharged and charged objects, and the dangers of static electricity, uses of static electricity, Van de Graaff generator, and electric field, and practical work done by the gold leaf spectroscope. These are the few topics which we'll be covering. So let's start. First of all, suppose you have a rod made of polythene. You have a strip or you have a rod which is made of polystyrene. Like you have your scales. They are made of polythene. I said polystyrene. Polythene. So rub it with the cloth. Rub that rod with the cloth. And then using a thread like the diagram which is showing on your screen, hung it with the help of a thread with a retort stand. Okay, like this. Hung it with the thread with a retort stand. You have taken a polythene rod and you have rubbed it with the cloth. And you have tied a thread with it and you have hung it with a stand. Take another polythene rod. Take another polythene rod and rub it with the cloth and hold that polythene rod in your hand and bring it near this end. When you will bring this near this, they are not touching. You just bring this rod, this second rod near the first rod. Both are polythene rods, both have been rubbed with the cloth. And when you will bring it near the first rod, which is hanging with the thread, you will observe that that rod will be reflected. When you bring this rod near this rod will be, if you bring this second rod near the first rod will move away. It will be like reflected. It will be like, repelled. It will be repelled. You will get the feeling that if when you bring the second rod near the first rod, they are repelling each other. You see, both the rods are polythene rods. Both have been rubbed with the same cloth. And when we try to bring them close to each other, they repel each other. Now do the opposite. Now take a polythene rod. Now I'm talking about another activity. Take a polythene rod and rub it with the cloth and hang it with the thread with a stand. Take another rod which is made of cellulose acetate, another material, a different material, and you take the second rod which is made of cellulose acetate and you rub it with the cloth, and now you bring it with the near the polythene rod which is hanging with the thread. You will observe they will be attracting each other. They will be attracting each other. You see, when the conclusion is, when you have two rods, you see, when a strip of polythene is rubbed with a cloth, it becomes charged. If it is hung up and another rubbed polythene strip is brought near, repulsion occurs. So in the second activity, attraction occurs when a rubbed strip of cellulose acetate is brought near. This shows there are two kinds of electric charges. The one, cellulose acetate is taken as positive and the one on the polythene is negative. It shows that the like charges, positive and negative, repel. The like charges will repel, while unlike charges, positive and negative, they will attract each other. So if you have same charges on two bodies, for both the rods have the same charge, for example, both of them have negative charge, they will repel. If both the rods has positive charge on them, they will repel. Like charges repel each other. If both the rods have the opposite charge, I mean, if one rod has positive charge, the other one has negative charge, they will attract each other. See, another very good example is, before we go into the further discussion, let me introduce you to another concept, that is where every atom has negative charge and positive charge in them. The positive charge is in the form of protons, and they are inside the nucleus. So in atom, we have in the center a nucleus. You have already studied this thing in your chemistry. And that nucleus, we have protons and neutrons. The protons are positively charged and the neutrons are neutral. They are inside the nucleus. And that nucleus hold that positive charge with a very strong force. You cannot take out that positive charge. The electrons which are orbiting around the nucleus, the electrons which are revolving in the orbits around the nucleus, they have the negative charge. The electrons, they can be taken out of an atom and they can be also given to an atom. You see, in a neutral atom, the number of protons and number of electrons, they are always equal. For example, if I say hydrogen atom, the hydrogen atom will have one proton, one positive charge in its nucleus and one negative charge in its orbits. So one electron, one proton. So as a whole, the hydrogen atom is neutral because it has the same number of protons and it has the same number of electrons. So atom normally is neutral. But you see, by some process, we can take out the electron. We can knock out the electron. We can take away the electron. If you take away the electron from a neutral atom, its charge balance will be disturbed. Now, if you take away electron, what happens? The atom becomes a positive ion because it has more protons as compared to electrons. In the same way, you can donate an electron to an atom. If you put an extra electron or two extra electrons in its orbits, now the balance will be disturbed between the positive and the negative. If an atom has accepted an electron, what will happen? Now it will have more electrons as compared to the number of protons. So it will become a negative ion.
Yes, sir.
So you see, we can, sorry, we have negative charge, which is the fundamental charge is electron, which is negative, and we have protons, which are positive. The main concept which I want you to understand and remember is that in this chapter, the electrons, they are given to an atom and that atom will become negative. The electrons are taken away from an atom and that atom will become positive. The electrons are given, the electrons are taken away. Never in this chapter, never in your physics, you are going to take away a proton. Never, never, never a proton is given or a proton is received. The proton cannot be isolated. It cannot be taken away from a nucleus. Only the electrons can be taken away. Electrons can be given. So whenever you are writing or whenever you are describing, you will never say that a proton was given to a body or a proton was taken from the body. You will always say the electrons are transferred. The electrons are given to the body. Electrons are taken away from the body. You see, whenever you will be writing the descriptions in this chapter, you will always say that the electrons moved to the body or electrons move away from the body. Never you will never say that the protons are given to the body, the protons are taken away from the body. Very important thing. Okay? So the electrons are in the orbits around the nucleus and protons are inside the nucleus. You cannot take out the protons. You cannot donate the protons. You cannot receive the protons. You only can do the business with the electrons. The currency is electrons. Okay. So this topic is very important, which is right now showing on your screen. Let me increase the size so you can actually read it. So you see, there is evidence that we can picture an atom as being made up of a small central nucleus containing positive charged particles called protons, surrounded by an equal number of negatively charged electrons. The charges on a proton and an electron are equal and opposite. So an atom as a whole is normally electrically neutral. That is, it has no net charge. Hydrogen is the simplest atom with one proton and one electron. A copper atom has 29 protons in its nucleus and 29 surrounding electrons. Every nucleus except for the hydrogen also contains uncharged particles called neutrons. So this is that diagram. In the center we have the nucleus where you have protons and neutrons also. Electrons are orbiting in the nucleus around it. The production of the charges by rubbing can be explained by supposing that electrons are transferred from one material to the other. When you rub the materials, like I told you in the first activity which I told you, we have a polythene rod and we rubbed it with the cloth. When you rub it, so what happens? The electrons can transfer from the polythene to the cloth or from the cloth to the polythene. Anything can happen. The production of charges by rubbing can be explained by supposing that electrons are transferred from one material to the other. For example, when cellulose acetate is rubbed with a cloth, electrons go from the acetate to the cloth, leaving the acetate short of electrons. That is positively charged. The cloth now has more electrons than the protons and becomes negatively charged. Note that it is only electrons which move. The protons remain fixed in the nucleus. How does the polythene become charged when rubbed? You see, try to understand this. There are two major examples which I have discussed with each other. One, I have a rod which is made of polythene and I rubbed it with the cloth. And another example, we have a rod which is made of cellulose acetate. It's a material. You rubbed it with the cloth and we came to know that the cellulose acetate will lose electrons. So when you rub the cellulose acetate rod with the cloth, what happens? The electrons transfer from the rod to the cloth. So the rod will have less electrons now because the electrons by the rubbing has been transferred from the cellulose rod to the cloth. If they have been transferred from the cellulose rod to the cloth, the cellulose acetate rod will have less number of electrons. So it will become positive. And the cloth which has gained more electrons now, the electrons has been transferred to the cloth. So the cloth will become negative because now it has more electrons. So you see what is happening here. When you rub two objects together, both of them are insulator. We will discuss this insulator thing also. So when you rub two objects with each other, what happens? The electron from one body will transfer to the other body. The body which will lose electrons, that will become positive, and the body which will gain electrons, that will become negative. So in the case of polythene rod, he said, what happens with the polythene rod? When you rub the polythene rod with the cloth, what happens? The electrons from the cloth will be transferred to the polythene rod. When you rub the polythene rod with the cloth, what happens? The electrons from the cloth are transferred to the polythene rod. If this happens because the electrons are transferred from the cloth to the polythene rod will become negative and the cloth will become positive. Because the cloth has lost electron, because the electrons has been transferred from the cloth to the polythene rod. If the electrons has been transferred from the cloth to the polythene rod will become negative and the cloth will become positive. So in general, you should know, if you rub two objects together, for example, object A and object B, if you rub two insulators A and B together, so from one it will be transferred to the other. Electrons will be transferred. For example, if the electrons are transferred from A to B, if the electrons are transferred by rubbing from A to body B, the body B will become negative and body A will become positive. Consider another scenario. If, for example, you rub two insulators A and B together and the electrons are transferred from body B to body A. Electrons are transferred from body B to body A. Then the body A will become negative and the body B will become positive. It's very, very important to understand this, this description, that why some body will become positive and why some body will become negative. And whenever you are writing this description, never you will never say that the protons have been transferred. It is electrons are always transferred.
Okay, sir.
You understand?
Yes, sir.
So another very important thing is the difference between what are electron insulators and what are conductors. You see, insulators are those materials in which the electrons are very, very tightly engaged, or you can say very tightly held with their nucleus. Insulators are those materials in which the electrons are not free to move around. The electrons are there. The electrons are there in the insulator atoms, but those electrons are very tightly held by their nucleus. They cannot go away. But in the case of conductor, you see, conductors have electrons in their valence shell, which are not that tightly held by their nucleus. So in the conductors, the electrons which are in the valence shell, they are loosely held. So what happens if you provide them a little attraction, if you give them those electrons a little initiative, or you give them little incentive, or you give them, actually the technical word is, if you provide them little force or little energy, they will leave their nucleus and they will go away. Those electrons are called valence free electrons because they are not bound to one. For example, metals. Metals are very good conductor of electricity. Why they are called conductor? Because they have free electrons. What are free electrons? Free electrons are electrons in the valence shell who can be taken away. And those free electrons, they do not remain with one nucleus. They are able to roam around. They can flow throughout the metal piece. But this is not the case with the insulators. In an insulator, all electrons are bound firmly to their atoms. In a conductor, some electrons can move freely from atom to atom. An insulator can be charged by rubbing because the charge produced cannot move from where the rubbing occurs. That is, the electric charge is static. A conductor will become charged only if it is held with an insulating handle. Otherwise, electrons are transferred between the conductor and the ground via the person's body. Good insulators include plastics such as polythene, cellulose acetate, perspex, and nylon. All metals and carbon are good conductors. In between are materials that are both poor conductor and, because they conduct to some extent, poor insulators. Examples are wood, paper, cotton, the human body, and the earth. Water conducts, and if it were not present in material like wood and on the surface of, for example, glass, these would be good insulators. Dry air insulates well. So we have two kinds of materials, conductors and insulators. Okay. So let me do the same thing from another book. This is the okay. So here we have, for example, if you have a plastic comb, comb, kangi, in Urdu we say kangi. If we run a plastic comb through our hair and then take a comb and rub it through your hair, take a comb, plastic comb, and rub it through your hair, and then take small pieces of paper, put them on the table, and rub that plastic comb in your hair. And when you will bring the plastic comb near those small pieces of paper, you will see, don't touch the paper, the comb. Yes. If you bring the comb which you have rubbed with your hair near the paper, you will see that those papers will be attracted to that comb. They will jump on the table and they will come and stick with your comb. The reason is because when you rub the plastic comb in your hair, the plastic comb has become charged and it is able to attract the paper. If we run the plastic comb through our hair and then bring it near small pieces of paper, the comb attracts them. You can see this here. I don't know if this is visible to you. Let me increase the size. You can see here a plastic comb is being brought near the paper and the papers are attracted. Okay. If we run the plastic comb through our hair and then bring it near small pieces of paper, the comb attracts them. Similarly, amber, when rubbed with silk, attracts the small pieces of paper. Amber is also a material. It's an insulator. If you have its rod, you rub it with the silk cloth and you bring that amber rod near the piece of paper, like the plastic comb, that amber rod will also attract the paper. This property of attraction or repulsion between substances is due to electric charges they acquire during rubbing. When you rub them, the charges develop on them. Either they become positively charged or they become negatively charged. And the reason of becoming positive and negative, either they have lost electrons to the other body or they have gained electron from the other body. We can produce electric charge by rubbing a neutral body with another neutral body. The following activity shows that we can produce two types of electric charges through the process of rubbing. Activity number 1. Take a plastic rod and rub it with the fur. And then suspend it horizontally by a silk thread, or you can say thread. Now take another plastic rod and rub it with fur and bring near to the suspended rod. We will observe that both the rods will repel each other. It means during the rubbing, both the rods were charged. You understand? This rod, plastic rod, this was rubbed with the fur and we hung it with the thread, with the stand. This second rod, this is also a plastic rod. We have rubbed it with the fur. So we believe that it also has the same charge as the first rod. So when you bring these two rods together, you will observe they will repel each other. Okay, so another activity, now take a glass rod and rub it with the silk and suspend it horizontally. When we bring the plastic rod rubbed with the fur near to the suspended glass rod, we observe that both the rods attract each other. You see now in this experiment, what is happening? We have glass rods. And one glass rod number A, the first one, it was rubbed with the silk and it was hung with the thread with the stand. And the second rod is rubbed with the fur. You see, one glass rod, the first one is rubbed with the silk, and the second rod, glass rod, is rubbed with the fur. And we believe that when you rub the glass rod with fur, or when you rub, uh, if you rub the plastic rod with the fur, and if you rub the plastic rod with the silk thread, we think that both of them will acquire different charges. So how we know they are different? Because when you bring the second rod near the first rod, they will start attracting each other. Now take a glass rod and rub it with silk and suspend it horizontally. When we bring the plastic rod rubbed with fur near to the suspended glass rod, we observe that both the rods attract each other. In the first activity, both rods are of plastic and both of them have been rubbed with the fur. Therefore, we assume that the charge on both the rods would be of the same kind. In the second activity, rods are unlike and their attraction implies that charges on two rods are not of the same kind but of opposite nature. These opposite charges are conventionally called positive charge and negative charge. During the process of rubbing, negative charge is transferred from one object to another object. From these activities, we conclude. What we conclude? That charge is a basic property of material body due to which it attracts or repels other objects. Friction produces two different types of charge on different materials such as glass and plastic. This is very important. Like charges always repel each other and unlike charges always attract each other. Repulsion is the sure test of charge on a body. Okay, here we have, here you can see, here we have a list. I don't know if it's visible to you. In this list, we have 12 names, 13 names. So, in the list given below, different materials have been arranged in such a way that if any of the two materials are rubbed together, the material occurring first in the list would have positive charge and that occurring next would have negative charge. For example, among cat skin and lead, skin has a positive charge whereas the lead, what does this mean? It means, for example, if you take glass and you take cat skin, so when you rub them together, the glass will become positive and the cat skin will become negative. For example, if I take silky cloth and I take plastic, when I take silky cloth and I take plastic, and when I will rub them, the silky cloth will become positive and the plastic will become negative. The reason is from the electrons from the silky cloth will be transferred to the plastic. Because the silky cloth has lost electron, that's why it will become positive. And because the plastic would gain electrons, so it has become negative. You see this list which is showing on your screen, it is very, very important. You don't have to kind of memorize it. You don't need to memorize it. But, it's very important. Okay, another very important thing is electrostatic induction. You see, for example, this is electrostatic induction means that, let me give you the, before I go into the electrostatic induction thing, when you rub, remember this thing, the insulators. In insulators, the body of the insulator can be charged. The insulator is basically neutral. The positive negative is neutral. But when you rub the surface of an insulator, you can disturb its balance. I mean the positive negative balance. So by friction, by actually rubbing, you can create local charge on a part of the insulator. On the surface of insulator, wherever you will rub, there the charge will be, it will become positively charged or it will become negative charge. You do not do this with the metals. You do not do this with the conductors. Remember this thing. This rubbing thing is not done with the conductor. This is done with the insulator. Okay? So it's very, very important to understand. So, here on your screen, you can see we have another activity. He says we have taken a plastic rod, and you see, if you charge a plastic rod and you bring it near a metal rod which is neutral, now it's a total different story. Okay, try to understand. If you have a metal rod which is a conductor, it has free electrons, they can flow in its body from one point to another point. If you have a metal rod which is actually neutral and you bring a charged body near it, you see, let me show you this. Let me draw a diagram so I can make it more. Wait. Suppose here I have a metal which is neutral. Here I have a piece of metal. Let's say this is aluminum and it is neutral. It has positive charges, it has negative charges, positive, negative, they are balanced, they are neutral, they are equal everywhere. So this whole aluminum, this is aluminum, okay? This is aluminum. Aluminum. Now I take a plastic rod. I take a plastic rod which is, suppose it has been rubbed in such a way that this rod has become positive. This rod has become positive. This plastic rod, the green color rod, is positive. So I will bring this charged body near that metal, near the left end of the metal. You see, it has free electrons. So when you bring this positively charged rod near this left end, the electrons in this, the free electrons in this metal, they will be attracted to this positively charged rod. And what will happen? The electrons from all over, they will be attracted here and they will accumulate here. So for example, for your understanding, I am showing here 5 electrons. So the free electrons in the body of the aluminum rod, they will be attracted to this positively charged body, which is held near the left end of the aluminum body. So the electrons from all over the aluminum, they will, because it has free electrons, they can move around in the aluminum. So they will come here and they will be sitting, the electrons will be sitting here on the left hand. So when the electrons, for example, I'm trying to show it with the 5 electrons. So when the 5 electrons will accumulate here, so here the deficiency on this right end, the deficiency of electrons will be created. So you see what will happen here. Here the 5 positives will appear. It is not that because from here the electrons has been moved. So what happened? Oh, due to this positively charged rod, which is not in touch with the aluminum. It is not touching it. This is not in contact with the aluminum. You just brought it near the left end of the aluminum. So you see what happened here? The free electrons from all the aluminum, they are attracted to this positively charged rod. So they will come and they will be accumulated here on this left end. So because the free electrons have moved here, so here a deficiency of free electrons will be created. So apparently what will happen? The left end of the aluminum will become negative and this right end of the aluminum will become positive. If you look at the aluminum as a whole, it is still neutral. Positive, negative, they are equal. But partially you can see that the left end it has more electrons than the protons there. And the right end has less number of electrons as compared to the proton. So the left end will become negative and the right end will become positive. And whenever we show this on a diagram, the number of negatives you show on the aluminum, same number of positives you will show on the other end. Another example you can consider. For example, if I have a rod, aluminum rod, which is totally neutral, and it has the same number of positive, negatives everywhere, it's neutral. And you take a plastic rod and you rub it with something, and we know that it has become negative. Now you see, I have a negatively charged plastic rod, and this brown color thing, that is aluminum. It's aluminum. It's a metal, and it is neutral. But when you bring this negatively charged rod near this left end, this has free electrons. The aluminum has free electrons because a conductor, it's a metal. It has free electrons. So the free electrons can move throughout the body of the aluminum. So when you will bring this negatively charged rod near this aluminum, so see what will happen. The free electrons in here on this left side, they will be repelled by this negative. And from here, the free electrons will go and accumulate here on the other side. So here you will see the free electrons will come and they will accumulate. You see, I have shown here 5 negative electrons coming there. If from this left end, the electrons have moved to the other end, here a deficiency of 5 electrons will be created and this end will show 5 positive charge. It is very important that you show the same number of charge on both the ends. 3, 4, 5. You see, when I bring a negatively charged rod near the left end of the aluminum rod, which was before neutral, the free electrons from this left side will be repelled by this negatively charged rod and they will go to the other side. So now the right end has become negatively charged and the left end has become positively charged. The reason is because it's a metal, it has free electrons and the free electrons can flow throughout the body of the metal. And due to the presence of that negatively charged rod on the left side, the free electrons have been repelled and they have gone to the right end. So the right end has become negative and the left end has become positive, deficiency of electrons. If you look at the aluminum rod as a whole, it is still neutral. But because more electrons are now on the right side, so that right side is negative and the left side is positive. You see, in these two examples, in both these examples, in both these examples, in both these examples, We have brought a charged body near a piece of metal. In both these examples, we have brought a charged body near one end of a metal piece. And we have observed that when you bring a charged body near one end of a metal rod, the two opposite charges are created on both the sides of the rod. This is called electrostatic induction. This is called electrostatic induction. Do you understand this electrostatic induction thing?
Yes, sir.
Okay. So, if we bring charged plastic rod near suspended neutral aluminum rod, both rods attract each other as shown in the figure. This attraction between the charged and uncharged rod shows if both rods have unlike charges. But this is not true. Charged plastic rod produces displacement of positive and negative charges on the neutral aluminum rod, which is the cause of attraction between them. But total charge on the aluminum rod is still zero. It implies that attraction is not due to short. This implies that attraction is not the sure test of charge on a body. The above activity shows that a phenomena that is called electrostatic induction, as explained below. Try to understand. This aluminum rod, let me increase the slide so I can explain you the wording of this article. Okay. This aluminum rod is totally neutral. This aluminum rod is totally neutral. We know that. We brought a negatively charged rod near the left end, and all of a sudden what happens, they start attracting each other. So when they attract each other, it gives us the feeling that the aluminum rod, which we were sure was neutral, but its left end is attracting to the negatively charged rod, which is brought near it. The reason is that the aluminum rod is perfectly neutral. We have not charged it, but when you bring this negatively charged rod near this left end becomes positive, and the right end of the aluminum becomes negative, because the free electrons due to this negative rod has been repelled from here, and they have accumulated on the right end of the aluminum rod. So this left end has become positive, and this right end has become negative. Now this left end is, because it's positively charged, and this rod is also negative, so they will attract. So never use attraction as a sure test to show that something is charged, because aluminum was not charged. This phenomena, when you bring a charged body near a metal body and charges appear on the ends of that neutral metallic body, this phenomena is called induction, electrostatic induction. You understand this?
Yes, sir.
Okay. So I think it's enough for today. We will continue with this. This chapter we have. This is the new chapter, and the name of the chapter is electrostatics. You see, we have learned today 2-3 things only. One thing which we have learned is about the atom. Atom has electrons in its orbits, positive and negative charges, neutrons and protons inside the nucleus. The protons cannot be taken out from the nucleus, or they cannot be given to the nucleus. Electrons can be taken away from the orbits, and it can be given to the orbits. So when something will lose electrons, it will become positive ion, and if it will gain electrons, it will become negative ion. So during this chapter, I have tried to explain to you that during this syllabus, during this chapter, only give and take of the electrons will be done. If a body will become positive, it has lost electrons. If a body will become negative, it has gained electrons. Never, 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 never in your explanation you will use the word protons. Okay. The second thing we learned is how the insulators are charged. We learned that insulators are rubbed against insulators and they become charged. And the second thing we have learned is what is electrostatic induction. This thing will go on in the next lesson also. Okay. So hopefully you have understood this. Just the introduction. We are starting this new chapter, electrostatics, and we will continue with this. So I hope this is you will be able to understand this concept. It will take 1 week or 1.5 weeks to complete this chapter. So ji, thank you very much and have a good day.